So thank you for taking the time out to attend and discuss generative AI and our solution. So we'll just dive right in and go ahead and start. All right. So first of all, we are going to be discussing large language models and generative AI systems. There's a lot of companies that are offering these as software as a service. And the key point to understand is that Progress Software and the Progress Data Platform doesn't actually create these large language models or generative AI systems, but we use them in various pieces in our solution, and we also make their answers much more reliable, accurate, and transparent, and that's really what we'll be talking about today. So these third-party products, of course, are things that are not under our control, and we are not able to I guess, be responsible for what they produce. So that's just something folks need to be aware of. All right, what we'll be doing is we'll be talking about generative AI concerns and risks that affect business value. Then we'll go through a demo that demos various kinds of knowledge retrieval and data availability and data security. And then we'll talk about sort of what we saw in the demo in terms of an architecture. We'll be going over 3 different architectures. One is just straight out asking generative AI systems questions. The second one is to help the generative AI to use the generative AI system to help understand the meaning of the questions and find the right content. And the third one is to use semantic graphs that are validated by human in the loop, in addition to the generative AI semantics. So we'll talk about sort of what's under the hood after we do the demo. All right, so suppose you're getting ready to launch an AI initiative. You've gotten approval, you've gotten budget, your CEO is eagerly awaiting results, and you're getting ready to you're gearing up to go. But remember, when you're building a brand new rocket, there are a lot of potential failure spots, and a lot of things can go wrong. So let's cover what are the key causes of things that can go wrong. This quote from Gartner was really instrumental in some of our thinking, which is they believe that by the end of 2025, at least 30% of GenAI projects will be abandoned. And I actually think the number's higher. I'm going to guess it's going to be close to 50%. I've already seen a lot of customers that have gone through and done pilots and then said, nope, not ready for prime time yet. And the reason for not being ready for prime time is the stuff that I've highlighted in green, which is poor data quality. Your garbage in, garbage out problem exists whether you have generative AI or not. Inadequate risk controls. There's a lot of things that the generative AI could be responsible for in terms of what it returns and what decisions are made on it, and being able to understand the accuracy and the risk related to the accuracy/inaccuracy of the product can be extremely harmful to the project success. Also, generative AI systems cost a lot. Inferencing is not a inexpensive cost, and we will go through some of the clear capabilities that we bring to the table with patent pending technologies that help you really focus in on and reduce those costs. And then because of the risk and because of the quality and the costing, business value can become murky or unclear, and we're trying to help you address those as well. So we've been working on for the past 2 years what we call semantic RAG, which is a combination of semantics derived from a lot of different tooling and tool capabilities. RAG is retrieval augmented generation, and really it's a way of finding data within your private enterprise that is securely available to your end users based on their roles. Once you find that right data, providing it to the genAI, that can give you transparency because you're giving it the data You can see your sources. You can see what the generative AI generated from those sources. Um, if you can capture the expertise from your subject matter knowledge workers, subject matter experts, you can then use that expertise in a lot of different ways in the semantic RAG system to improve accuracy, provide real-time capabilities, adapt in real time to learnings that your subject matter experts are being able to receive. And then also, because we have the ability to understand what's important, what's not important, we can help you reduce costs in the of the overall solution, including inferencing costs, including text embedding costs. So there's a lot of places we're going to go through on the architecture side to show you how those costs can be reduced. And so with that, we'll go to the next thing. Some of the key concerns that generative AI systems have are that they hallucinate. They create what's very credible looking answers that are completely wrong or partially wrong, or sometimes just a little bit. But the really interesting part is what I would say is the confidence in which they state the incorrect answer is very high. And so that's one. Another is if your data is biased, your answers are going to be biased because you're giving the generative AI biased data to look at to begin with. Another issue that generative AI systems have is understanding and being able to do reasoning in a very succinct manner. And reasoning tends to become more easily done if you provide the right information. Then it takes a year and a half to 2 years to train these systems. So data cutoffs, missing information is an issue. We already talked a little bit about explainability and the robustness of answers. And so how do we think about these things? Well, we think about the context that we're providing the generative AI as the super important aspect of helping solve these problems. And I'd like somebody who hasn't seen this presentation to volunteer and tell me what they think is in the image in behind the context is king. And there isn't really no right answer at this point. So Diego, perhaps you can answer or take a guess.
No, I'm okay.
Hi, Aaron. I guess it's because when you are providing pieces of information that really is related to the business of the user. I guess that's the question. That's the best answer.
Yep. So it is related to the business of the user. So, but my question is, what do you think is the picture? What is this picture of? Now, I only gave you a small piece of that picture, not the full picture. So you have very little context. So that's sort of my question.
I got it.
So, do you want to take a guess as to what you think this or this is?
Have no idea. Ocean.
Okay, all right, fair enough. Good enough
For
as an
for
answer.
for us, it's new. Or
Sorry, repeat that.
for us, it's new.
Yes, exactly. So you have no clue what this image is all about. Now, if I show you this full thing, can you tell me what this image is about?
Game of Thrones.
Yes, exactly. So again, see, if you only get a small piece of the data, you're not going to be able to answer properly. But if you get all of the right data that you need, then your answers become really relevant. And it's the same with generative AI systems. All of these things that we're talking about here, the probability of these errors goes way down when you give it the full context and the right context. All right. So another really important piece of the puzzle is Forbes came out with this early this year that said this is not the year of AI, it's the year of proprietary data. How can you get the AIs the right proprietary data? And so that also feeds into the previous slide here. Next, let's start going through some examples of this. So we'll do a demo. We'll talk about trustworthy knowledge retrieval. We'll also give you a quick example of availability and security. And we'll talk a little bit about the knowledge that we're going to go ahead and show you. So over here in this demo, we will be talking about basically our own public data. So we're a tech company. We have product documentation, and our customer and customer support people can ask us questions about that. And so that's what we'll be demoing today. So flipping over to here, and I'll just go full screen. We have three different ways of looking at it, and I briefly touched upon them. The first one, we're just going to ask the generative AI system, and in this case, it's 4.0 that's creating these answers. The question in the middle tier, we're basically asking the generative AI system itself to create semantics and meaning from the questions and answers. And in the third tier, we have the generative AI semantics, but we also have human in the loop validated graph information. And throughout this demo, I want you to pay attention to the last one, because the last one will tend to be right most of the time, because it has a more sophisticated understanding of our business. All right. So with that in mind, I am going to go completely off script, because it's always good to sort of see what happens when you just ask a random question. So if somebody who's watching can go off of mute and ask a question that they might want to ask about ChatGPT today. David, do you want to go ahead and ask a question? Not necessarily to do with MarkLogic or MarkLogic documentation.
I don't know. It's
very random. Go ahead, just ask anything that comes to top of mind that you might be interested in asking Google or a genAI.
Can I?
Yes, go ahead.
okay if you have one.
What is the latest on the Brian Thompson death? Latest news on the Brian Thompson death?
On the Brian?
He's talking about the shooting.
The shooting, yeah.
Thompson?
Yes.
THOMPSON shooting?
Yes.
Okay, that sounds like an interesting thing to ask for. Let's do it. Now, in advance, I'm going to guess that these two guys are going to not want to answer that question, but we'll see.
No one will answer it.
Well, the 4.0 has access to the internet, so it may or may not answer. We'll see what it does.
That is a slightly confusing actually. It's 4.0. From the documentation I was looking at it, it looks like the ChatGPT is what is actually accessing internet, not the model. But okay. I might be wrong in that actually. I'm not very sure. But
yeah. So it might not answer. Okay. So all of these guys answered unsure, which is fine.
But what just ask like who is Brian Thompson, right?
Okay. All right.
Because that is an older information.
Yes. Okay. So let's ask that. Who is Brian Thompson? And let's submit this question. But one thing in the previous question that I want you guys to see is that it said no, but it said I don't have any documents related to this, right? So this is an example of how you can ask the AI system to focus in on just the documents, the private documents that you have. And in this case, again, here, we don't have any answers to any information on Brian Thompson in our documentation. So we got basically no answer. Over here, the AI system tried to give us an answer, and it may or may not be the right Brian Thompson. But all right. So this is just showing you that, going off script and being able to handle going off script from users is important, because when you give these systems to end users, they will use it in ways you never imagined, because that's what users do. So now let's ask a question about MarkLogic and digital twins, and let's go ahead and see what that gives us. So can you provide me an example of where MarkLogic was used for digital twins? Now we do have that data in our database, and if you notice, I'm using the MarkLogic All reader, so this reader has access to that content, and it should be able to give us good answers. I'm going to go out on the limb and say these guys are going to give us good answers, and I'm going to withhold judgment for this one because So it looks like when we look at this, we are getting some information about digital twins and Mark Logic and that sort of thing. So it looks good. But then if I click on Mark Logic blog digital twins, I actually don't see anything about digital twins on this page. So I'm going to give this guy a thumbs down because the sources that it gave me are not valid. On the other hand, if I come here and look at the source, I can see that yes, Boeing integrates digital twins. I can see the page or the pages that were used to give us that information. And I can actually click on this and get the original information and go, okay, yeah, I can see digital twins and I can understand why this was answered positively by these two systems. Any questions on this? Is that making sense to folks?
Yes, it is.
All right, great. So next, we're gonna show sort of the difference between the middle and the most advanced solution that we have. And this is, if you think of it as is sort of our progress data platform solution, the one on the right-hand side. So what I'm going to do now is I'm going to ask the same question, but ask it about device shadows, which is a much less well-known synonym for digital twins. And we have captured the fact that this is a synonym for digital twins in our knowledge graph in the semaphore user interface. And so this one says, nope, no information about device shadows, nope, information about device shadows. And this one, if you notice, says digital twins are also known as device shadows. So this one is able to reason that synonym understanding of the content because we gave it that information from the knowledge graph into the prompt and we got the right answer. So this one is what I'm going to go ahead and give it a thumbs up here. Now, I could just as easily have asked for any of the other 20 different ways of saying digital twins, like cyber replica. And I should get the same results. Very low probability of these two answering the question, and a very high probability of this one answering the question. Again, these are probabilistic systems, and every time I run this thing, it's never 100%, but 99% of the time, I'm pretty confident this guy's going to give us the answer. And so there you go, right? So now how are we doing this, right? What is really going on under the hood? Well, we have a model here that this demo is using, and over here in the model, you can see that there is a concept of digital twins. There's a concept of flex rep. There's a concept of data models. There's a concept of cost of vectorization and so on, right? If I were to click in, and this is the semaphore user interface that every end user in your company can access and use. If I were to click on digital twins, I can see the details of digital twins. And you can see here, cyber models was here, cyber replicas was here, cyber twins was here, and so was device shadows. And if I were to scroll down in the actual user interface, I would see that there's like another 15 more synonyms here. And just by having sort of this relationship of these tokens or these descriptions associated with the concept of digital twins, we were able to answer that question, even though the user may be more familiar with one of the other synonyms. And you can see this happening in a lot of different places. Where this capability really shines is when you have, let's say, internal part numbers, or you have brand names versus generic names, or you have chemical names versus brand names versus generic names, right? So all of them are referring to the same concept. Depending on who's asking the question within your company, they may be more familiar with just one of them or multiple ones, but typically not all of them, right? And so the ability to capture this concept and understand how it can be called within your document and your data sets is what's giving us this edge. All right, so what we just demoed to you is how you can get trustworthy knowledge, how you can look at the sources, how you can explore the knowledge graph itself as an end user so that you can get your right answers, reduce your risk, and increase your business value. Next, we're going to go over availability. So flipping back over to the demo here, if this is the all reader, and if with the all reader, we added new data that is that initially was actually only available under NDA because we hadn't filed for patents. And so now we're going to ask a question about that. So one, this is more relevant data, but two, it's also data that your regular MarkLogic public reader cannot see. So here we get recent data as well as sort of secure data, and we can go back and look at the actual documentation, which has the information in it. So the ability to see that is great. Over here, so I'm going to go ahead and give these guys both a plus because they were able to get the more recent data that the all reader can access. Over here, on the other hand, when I look at progressive vectors, it's not talking about MarkLogic because I didn't ask about MarkLogic progressive vectors. I just asked progressive vectors, and it's going down fuel consumption and minimizing fuel and recalculations and things like that. And if I were to go back and look at this page, there's nothing here about progressive vectors, right? So again, I'm going to give this guy's a thumbs down. All right, so now I'm just looking at the actual security considerations of what we're going to do. We're going to look at another reader, the MarkLogic public reader, that doesn't have access to the NDA documents. And when we built this demo, these were under NDA, so this user should not be able to answer the question. So let's go back and log out and log back in as the public reader. And so now when I sign in and go back to the same architectural view, we can see that progressive vectors here, and let's go ask the question. And I'm going to go out on a limb and say all these guys are not giving me the answer, and let's see what they do. So again, this one is hallucinating. We can double check and see. Food fraud, yeah. Supply chain brain. Let me check for the word vectors. Yeah, vectors are not here, right? So it's just making stuff up. And that this is a real problem with these genAI systems, right? So and over here, these guys, even though the answer was in the database, were not able to answer because this reader did not have access to that content. And so,
Well, you can argue that is the correct answer because if it had given data,
sure,
it'd be giving away sensitive stuff that they're not supposed to know about.
fair enough. Well, let's go with that interpretation and then give these guys a thumbs up. The thing to think about is within a corporate organization, there might be hundreds or thousands or tens of thousands of different security domains. And typically corporations use Active Directory to assign roles to people. Those roles get approved by the person's manager. So there's like a level of responsibility and security built into organizations. If you had to create custom semantic models for each role, that would be a lot of work. On the other hand, what we're doing here is we're using a single generative AI model, a single large language model, but we are figuring out who the user is, and based on that user, only feeding the generative AI the data that that user is allowed to see. And this kind of security capability has been built into our system from the ground up. We've been doing this for the last 20 years because public organizations and large governments will have thousands of security roles. That's just the way life is. All right, so we talked about availability and security, and how we can totally lock down your content and feed that content through to the genAI based on the user's privileges. So these are the things that we're doing to help our customers really launch successful products, go from pilots, which are easy, to production, which is hard. Right. And the proof is in the pudding. We've got customers that are doing this today, and they have actually seen super accurate results as as a result of the architecture that we've put in place, right? So a car company went from 50% to 90%. A leading chem company went into production in weeks. They already had their data in our platform. A leading accounting firm is using us as their secret sauce, and they have about 6,000 users on the system and are saving millions every week. A leading pharma company, when they first put together their knowledge graph, that the example of which I showed you, initially hit 80% out of the box. Typically, with text embedding models, this success rate is someplace between 50 and 70%. So even just out of the box, with very little effort, we were pretty high. But within 2 weeks of effort of actually looking at the answers that were coming back and minor changes to the graph, they were able to hit 98% accuracy. And the reason why these guys chose us is because of this ability to, in real time, change the graph and get better results, not just for AI systems, but also for humans, right? They've been doing this with our system for a good half a decade already. And then a leading tech company did some extra work up front and were able to hit 99+% accurate answers for their use case. And the quote that I got from the main engineer on this project was, all of the answers we asked were accurate and complete. I like the and complete part, because not just being accurate, but also making sure you get all of the rounded edges of the answer are important. All right, so now let's dive a little bit under the hood and talk to you about how we did what we did, how the right-hand side consistently got the right answers. So the first architecture is the one on the left, and it was really a closed book exam where you ask a question, you get an answer, and you have all of the issues that we talked about with generative AI systems. Also, you don't have any access to your private data, and the generative AI system just tries to answer based on whatever it was trained on for the last 2 years, right? So this is understandably going to be very weak in its answering capabilities across private data sets. The next thing we said was, okay, let's use the generative AI system itself to look at semantics. And so step one of this puzzle is to bring your private data into a repository that is searchable, discoverable in a lot of different ways, including semantics based on text embedding models. So you can build out vectors in Mark Logic as well, and have some semblance of semantics going on here. The other thing that we did is, when the user asks a question, we take the question and we feed it to the generative AI system. And we say, guys, can you tell us what's important in the question? And based on the generative AI's response, we will reprioritize what we search for. So that'll give us a nice set of data, and presumably you could, depending on how large your context window is and how much data you can feed the genAI, you might be able to feed 50 chunks of data, each of which might have 100 sentences. You might be able to squeeze in 5,000 sentences into the genAI and then ask the question, and so the genAI then responds, right? So this was a step in the right direction, and we started doing this very early on, probably about 2 years ago, close to 2 years ago now at this point. But then we said, we can go a level better because we are a semantic graph authoring company. Let's use that as part of our solution. So the Progress Data Platform combo of Semaphore and Mark Logic together is what that right-hand architecture looks like. It's still RAG. You're still storing stuff in Mark Logic. You're still asking the question. But now, when you ask the question, you have 2 places to generate semantics from. One is the genAI system itself can help us, but then also the graph that we have captured from the subject matter experts can be used to help us find the right data. So now when we do the search, we have a better understanding of what we're really looking for, what the user's intent is. We can fine tune the relevancy for each use case. And so that can give us a very nice set of, say, top 50 chunks, which again could have 1,000 sentences. But then even here, we can take those 5,000 sentences and say, you know, out of these 5,000 sentences, only 800 have semantic concepts that we as a company care about. So let's filter this down to just 800 sentences. So when you reduce the number of tokens you're sending a GenAI and increase the content context, then you're going to get faster answers and more relevant answers. And so that's what happens next. The other thing we've asked the generative AI system to do is give us references back so we can find the right data, so users can look at the right data and validate. We've also provided that feedback capability so we can get feedback from the users and track if we're getting drift or track bad answers. The right answers can also be cached and can reduce the need for doing generative AI if it's a frequently asked question. You could have a time to live on that, just like any other cache, right? So all of those things come into play. We can also create links back into Semaphore because Semaphore has an end user interface where end users can just browse concepts. So if I were to browse the concept of digital twins, I could see, oh, you know, digital twins are also related to manufacturing models or manufacturing recipes, right? And so I could then sort of focus in on a tangential similar concept that would be of interest for me and ask a follow-up query, right? So this capability is also really nice in sort of the Progress Data Platform. Any questions? There's a lot going on this slide, and typically people ask questions on this one. All right. The next thing that we'll talk a little bit about is actually in here in MarkLogic we have a lot of different ways of finding data, and so the next slides are a little bit about how all of those ways of finding data, basically all of the tools in your toolbox, can help you get better content for your generative AI and also improve accuracy. So this was a study done by ZetHub on a data set that is published by Stanford. They have about 20,000 paragraphs, and the way the paragraphs, and about 40,000 questions, and the way the questions are structured is one and only one of those content paragraphs gives you the right answer. So it's really easy to figure out if the system that you're using is getting you the right content. And if you only have the ability to get one paragraph back, then it doesn't really matter what tech you use. About 1/3 of the time, you're just going to be flat out wrong, right? On the other hand, if you have the ability to get 10 pieces of data back and can fit 10 pieces of data in your generative AI or give 10 pieces of data back to your user, now you're starting to see some differentiation going on. So what's the red line? The red line is a BM25 search capability against this data set. The blue line here is a vector embedding search capability against this data set. But what was really interesting is in this study that they did is they said, okay, when we combine the two, we get better results, which means that multiple tools will help you find the right data more often. And if you find the right data more often, you will get better answers, right? So the combo of these two things is really important. Now, our customers, though, are saying, hey, you know, Imran, even 90% is not good enough. I want to get closer to 100%. These are probabilistic systems. You're not going to hit 100%, but you can asymptotically get closer and closer. And what we've found is that our customers, when they use custom graphs, are able to hit that target. And so here's a real world example that we did about 7 years ago. Yeah, about 6 or 7 years ago now. And really the customer wanted the correct answer to be served up in the top 3, no matter if the correct answer existed in the drug product label, you know, that little white thing with very fine print that nobody reads. So if you follow this graph and go to 3, you're like, okay, BM25 isn't going to help. Vector text embedding is not going to help. Even combining the two is going to get us to 83%. That's really not hitting the 100% or close to 100% target that the customer wanted. But we were able to hit it. We created a custom graph, and that custom graph for all of the questions they asked, and they asked like well over, I'm going to say well over 100 questions, right? We were able to answer all of them accurately. In the top 3, the answer was always there, and 90% of the time, the answer was the first answer, right? They weren't feeding these answers directly back to the customer because of the sensitive nature of the answers. They did feed those to their customer service representative. So, okay. So another really interesting piece of the puzzle is semantics and sort of why compression in semantics is important. So I took a very large picture, I compressed it 1600 to 1, got 21 KB, put it into this PowerPoint slide, and the PowerPoint gave me this is a close-up of a hand. And the next thing I did was, okay, let's make it 800 to 1. And just remember these compression ratios because it's going to come up in the study that we're going to talk about in a second. And it still doesn't get the answer right? It goes, yeah, I think it's a line because there's kind of a line that's going off right through the middle of this picture. But then when I did 800 to 1, it said it's a body of water, and it could have added sort of islands in the background, and it could have, if it was a betting man, could have said this is a sunrise or a sunset, right? But at least for us, we can get a little bit more granular than what the AI auto-generated text was. This is the real image. This little thing over here is a ship. This little curvy thing over here is a bridge. And, with this whole context, again, context is king, we are able to answer the question of what this picture is about very easily. Now, this chart here gives us sort of the top 4 or 5 OpenAI models and their capabilities in terms of vector size, parameter size, how much training data went into it. And over here, this is the interesting one, 1600 to 1 compression, 800 to 1 compression off of the training data set, whereas ChatGPT was 3 to 1 and 4 was 8 to 1, and Google Gemini is in the 8 to 1 range. But really the point I wanted to get to is when you start compressing content or knowledge at this high level of compression ratios, you get less understanding of the real world. That's just how it's going to work. On the other hand, when you compress a lot less and use a lot more data, you get a better understanding of the real world. So these things can pass the bar exam. These ones can't pass the SAT, right? It's just the nature of what it is. But if we have a billion chunks of data, we're going to use this stuff and not this stuff because this would be cost prohibitive right now, in today's dollars at least. So the other thing to bring in a little bit more understanding in terms of what we're doing is sort of our human in the loop capabilities, and we've been doing this for well over a decade, and combining it with genAI is the new stuff that we've put in place, and our latest version of Semaphore, for example, and our middle tier that helps interpret the questions is sort of that combination of human in the loop and genAI working together. And going back to this slide, the question I almost always get from my customers is, Imran, great, but I don't have an expert team that can build me this graph, and I don't have an expert team that can build me this graph for each and every use case that I want to deploy. How do I get there rapidly? In fact, I literally had a conversation with a customer 2 hours ago where we talked about his first use case, extremely successful, going into production. Second use case, he's like, the next set of teams are in different countries and they don't have Semaphore expertise. How do I get them there fast? And so that's what we're going to talk about next. And so we have the vector capabilities, so we can do automated semantics from there. In the Semaphore product, the initial way of doing things, this would, I would say, be more than 5 years ago, was assign subject matter experts, train them up on Semaphore, and have them build out knowledge graphs that then the whole company can use for whatever use cases they want. And now those use cases include generative AI, but we have a lot of customers using these for all sorts of use cases, such as PII detection and research and all those kinds of things, right? But then about 5 years ago, we said, you know what, we can provide end users access to this and create a knowledge review tool where the end users can provide suggestions. Hey, you're missing a synonym here, or you're missing a relationship here. But they only provide the suggestions and don't actually change the graph, where the subject matter experts then review that. And so that has been very helpful in creating and refining the graphs more rapidly. But then when genAI hit the scene, we're like, oh, okay, now we can give the subject matter experts access to the genAI, and they are all of a sudden becoming 5, 10, 50x more productive than they used to be in terms of creating the concepts that they need, right? So this is what we got going on. On the text embedding side, we have to use those small models because we just talked about it from a cost perspective. But when you combine both of these things, you get really good semantic search. And that's how you're going to get the accuracy, reduce your risk and liability when you go to that space. But then we started thinking about, all right, how can we even continually crank up the accuracy of our systems? And how can we understand what the users are interested in from these systems? And so because we're already watching the users to understand their question, we can also take that same information and check our graph and go, hey, does this concept exist? Does this relationship exist? And if it doesn't, we can pretend to be an end user and feed back that information through our knowledge review tool for the subject matter experts to review. So 90% of what we just talked about is already in production today. The only thing that's sort of brand new is sort of interpreting what we do with the concepts that the generative AI system is extracting from the user queries. And this is a really, really rapid way of helping you generate graphs that are very tailored to what the users are interested in. Then the other thing that we said was, well, you know what? We know how to get you into the ballpark based on what the user's asking, because we have graph capabilities, we have search capabilities, we have tabular search capabilities, we have SQL-like query capabilities, we have co-occurrence capabilities, we have in-memory caching capabilities, we have in-memory formulas that you can create on your caches. We have geospatial capabilities, right? So there's a lot of capabilities we have to find the right data even without vectors. So the next question we asked was, well, if we can get you in the ballpark, and if your users are only interested in 10% of your data, why should you spend the cost and effort to vectorize all of your data? And so that's what we call progressive vectors, where you're only vectorizing what users are interested in. And think of this as a vector cache for your data, as opposed to vectorizing all your data. All right, so I've talked a little bit about a lot of things here and a lot of sort of innovative things that we've been doing for the last year or so. Are there any questions on this particular slide?
Well, I guess I mean we have to digest before
Yes.
bringing accurate questions, if I
Okay.
can say
Fair enough.
this way.
And you will have my email, and so feel free to reach out to me and as those questions come up, and we can have those discussions.
Appreciate it.
This is just a summary of what we just talked about in the previous page, right? Progressive graphs and progressive vectors and the benefits that they bring to the table. And so now we've just gone over all three architectures and why we can get our customers to those super high, arbitrarily high levels of accuracy that they need for their use cases. And really, that's the key to being able to go from a prototype that works 50 to 70% of the time to something that works to the level of risk that the company is willing to tolerate. And that's it. Thank you so much for your time, and I'm going to stop the recording now.
Thank you, Dr.
So Imran,
Amazing.
Let me hit stop here. All right, awesome.
yeah,